Today we are turning our focus to the LangChain messages. So unlike the previous video, we are not going to invoke the LLM client with a single string. We are going to send some structured messages. It works with this type of dictionaries that are standard in all the SDKs like Mistral AI, OpenAI, and some other ones where you provide the role and the content. However, in LangChain, there are also some built-in classes that will make our work much easier. So I would really encourage you to use these classes. You find them in langchain_core.messages, and then you can import the SystemMessage, HumanMessage, AIMessage, and ToolMessage for your different use cases. So I create a client. I will use Chat Mistral AI, but feel free to use a different provider if you wish so. And I start by importing the HumanMessage. So I don't send a single string, but instead I create this message, and I just need to add some content inside, which is the string that I want to send to the LLM. Be careful when you are working with messages in LangChain, it needs to be a list of messages. So don't forget the square brackets at the beginning and the end. And here I send a single message, but you could send a list of several messages as well. And whatever is returned by the LLM, I will save it in this response variable. You see that when I do this, actually, I receive automatically an AI message from LangChain. So this is something which is done automatically in the back end. And the good news about that is that it's much easier to work with this type of classes than it is with the standard SDK. If you remember in some previous videos, we had to extract the text we wanted to display to the user by using response.choices, index0.message.content. That was quite long to type very often, and when we wanted to append the message, we had to use response.choices index0.message. So that was something which was not very convenient. Here you see that within the class, there are different properties, and here this is the response from the model, so I can just access the content property and that's it. So response.content is everything I need to get the text to be displayed to the end user. So extremely easy. This will be the same when we are working with the tool calls. Here we don't have any tool calls, of course, because we didn't connect any tools to the LLM client. However, when this is the case, the tool calls are also part of the response, this AI message from LangChain. In that case, an empty list as we expected. You can also very easily extract the metadata, for example, here more specifically for the usage, if you want to track the number of tokens that you used. Everything is extremely easy to extract. This is the main benefit of working with these messages. Also, all these built-in messages, so not only this AI message, but also human, tools, system, they have this method, prettyprint, that make it very easy to display the messages in a nice way, so you don't need to deal yourself with the formatting. This is provided automatically by LangChain. So here I took my AI message and I tried prettyprint, and you see that there is a kind of header with the role, so you know who is talking in the conversation, and then there is the text. So then if you're working only with these LangChain messages, so for example, if I don't use the dictionary notation, if I don't provide a single string, but I use a human message instead, it will be very easy for me to look through all the messages in my conversation and use prettyprint, so I can easily display the conversation in the notebook. And this is what we are trying now. So additionally, here I will also import the system message, so I can add the system prompt, and I will save it in a list. So memory will be my list that contains all the messages from the conversation. So here I will start with a system prompt and my own prompt, and when we go through the conversation, I will also append the different responses that we get back from the client. So my system message, just your travel assistant, and my own message is just hello. Optionally, you can provide a name, which will be also part of the prettyprint to see who is talking, but this is completely optional. I just add it here to show you this option. Once we've got this list, we can invoke the LLM as we are used to, but remember that you are not obliged to give a single message or a string. You can also pass a list of messages. So in that case, I pass the memory variable, which is a list of different LangChain messages. After that, as soon as we receive the response, you see that it's very easy to append it to the memory. It's directly the entire response message. So as we discussed, we don't need to use response.choices index0.message. It's extremely short syntax. And after that, also as we discussed, we can just loop through all the messages in the memory list, and each message we pretty print it. So we can display the entire conversation in a way which is easy for us to read. And here you go. You see that we start with the system message. It's also possible to skip it if we want. We will improve the loop a little bit. If this is what you wanted to show to the end user, you will typically hide this system message. But if you want to debug your application, that's quite good to have this option to display it. So here we can see the conversation as we expected it. You are a travel assistant, hello, and then the response from the LLM. In case you want to skip this message, it's very easy to check what is the type of the message within the loop, because we use these built-in classes from LangChain. So we could say if not is instance, we want to check the type of the message, and we want to make sure that this is not of type system message. And if our message is not a system message, then we can pretty print it. So you could do something like this, and very easily you skip the system message and you then just print the other types. So human, AI, possibly the tool messages if later you are dealing with them and you want to show them to the user. I will just add a couple of additional messages. So I send a follow-up question and I will get the response from the LLM because I need it for the next section to get a bit more messages. So here I'm asking as a follow-up question. So I add to the memory a human message. So what should I visit in Brno? Still with my name. And then I invoke the LLM client with the updated memory list. After that, I can directly add the response to the memory and pretty print it. So here we don't have the exception to skip the system message, so we see the entire conversation. So one thing that also is quite easy with LangChain is that they provide different functions to work with this memory. So far we were just working with some plain Python list, but you can also use some functions or some different classes, depends on the strategy you use, from LangChain to work with the memory. So when it grows, for example, and you are close to your maximum context window, there are some ways that you can trim the messages. This is what we are going to try. You can summarize the conversation. There are different ways to deal with this to make sure that you are still keeping your entire context within the limits of the context window. Here, still from LangChain_core.messages, I import a function which is called trim messages, and as the name indicates, this is to remove some messages from our memory. The first thing to do is to save in a variable the configuration of this trimmer. So I use the function trim message, and then I can use different configuration item to simply configure how I want messages to be trimmed. Here I added the reference to the documentation so you can find more info about each parameter, and there are a few other that I haven't added that you can have a look at. So here max token 3. So the name is a bit misleading because when I use it together with the token counter len, it means that I'm not dealing with tokens, but I'm dealing with messages. And this is what's written in the different comments. So when I have this together with here max token 3, it means that I want to keep 3 messages. If I wouldn't have here len, but a different syntax, it would really count the number of tokens to keep in the conversation. The strategy last, it means that these 3 messages I want to keep the 3 last messages. You could change it, for example, to first, and in that case you will keep only the first 3 messages. Include the system prompt. Here, this is a simple boolean, whether you want to include the system prompt or exclude it. And start on human. It means that you want your trim list to start with a human message. Except if you added this boolean to true, it will start with the system otherwise it will start with this human. So let's have a look. I used the trimmer that we configured, and you can see this consistency in LangChain. The trimmer is a kind of runnable, so you still have an invoke method, like when you work with the LLM client. And I pass my full memory. Here we see that we receive indeed 3 messages, and as we indicated, it starts with the system message. And then we see that it removed the beginning of the conversation to keep only a total of 3 messages. And here, these were the 2 last questions, or the last question I asked and the last response I got from the model. Then you can play with these. For example, if we would have said that we didn't want the system, here, weirdly, you receive only 2 messages, and the reason is because you want basically to start with a human message. So if I will delete this one, you will see that here, 3 messages. I don't want to include the system message. We have 3 messages that are returned. However, if I add the condition, I want specifically that it starts with human, it will start from this pre-trimmed selection and delete the first one, so it really starts with a human message. So it's a bit confusing at the beginning. You need to really consider all the parameters to understand really what you get back. But with a bit of experience, it becomes a bit more logical. So in that case, we got these 2 messages. And so this could become part of your workflow, that whenever you want to reinvoke the LLM client, first you will send your memory variable to the trimmer, and then you can use this trimmed one. So you will assign it to a variable, something like you will say trimmed history, for example, is equal, and then you will invoke the LLM client with the trimmed history instead of the entire memory. So every time you can work on this type of trimmed one and append to the full memory. So you can work with kind of 2 different lists, the full one and the one that you are sending to the LLM. So that's one way that you can deal with this. Then also another simplification that we can do with LangChain, and this is actually, it comes from the name chain. So you can define the so-called chains to create a workflow in your LLM application. So here you see that this is a process which will be a bit repetitive. Every time we want to trim the history, then invoke the LLM and then display it to the user. So we could create a chain that achieves just that. So here you see that when you want to link different components together, you use this pipe symbol. And here I'm saying that in my chain, I want first that my inputs go through the trimmer. And after that, whatever will be the output of the trimmer will become the input of my LLM to invoke again. And then the output will be what I display to the user. So, and then you see that you don't invoke the LLM alone, but you invoke your chain. Once again, the consistency of LangChain, a chain is a runnable, so you have an invoke method. So here, if I invoke the chain with memory, it means that memory is the input of the trimmer, then it will produce an output, which is a trimmed conversation that becomes the input of my LLM. Then we can invoke the LLM with this trimmed history, and then the output is what will be returned by the chain. And here there is, I didn't respect actually the different roles. So I don't know if you can see the right side of the screen. It's written that it's expected the last role to be user or tool. And if we go back here, you see that the last message was an AI message. So I will need still to add a message before I reinvoke. So here, let's just add. So we said we can add to the full memory dot append. And then I will add directly a new human message. So then the content, let's say just thanks, and we will see how it works. So now I can reinvoke, and we see that this time it works, and I get a new AI message in return. You're welcome. I hope you have an amazing time exploring Brno. Okay, cool. There is another way, or actually you can expand your chain, and you can even include here string output parser. So the string output parser, this is the easiest parser to work with. This is just to display the content. So it will extract from the AIMessage the content and display it as a string. So there are two options that you could do here if you want to expand your chain. So you can use an existing chain that you have already created, and then with the pipe symbol, you just add another component, here the string output parser, or you could just recreate a chain from scratch. So you add your trimmer, pipe, the LLM, pipe, the string output parser. So there are no limits really to the number of components that you can chain within the LangChain chain. And every time it works exactly in the same way. When you invoke your chain, it goes to the first component, it will invoke it, then the output will go to the second component as input, and it will invoke it with it. The output goes to the third component, and so on. So each one will be invoked with the output of the previous step until we reach the last component, and we can just display the outcome. So here we will use this new chain, invoke it, and just pass the memory so it can go through trimmer, LLM client, and parser. And this is everything I can show you for now for this introduction to the LangChain messages. I hope you understand some of the benefits of using these built-in classes instead of the dictionary notation. And in the next video, we are going to work with the tools and do some functions coding. I will also show you why it may be easier to use LangChain for this type of process. So I wish you a good one, and I see you in the next video. Bye-bye.